Hi everyone, I'm Hiba Siddiqui,
I'm Nicole Page.
and today we're going to be presenting our project on network traffic classification using machine learning. So our project is focusing on classifying network traffic as either normal or malicious using machine learning models, specifically logistic regression and random forest. And we picked this topic because cybersecurity is becoming a bigger issue every day. And to us, it just felt like a practical and interesting application of what we're currently learning in class. And we were really curious to see if machine learning could help detect potential attacks based on patterns in traffic data.
So onto the data set. The data set we used is from Kaggle. It's from 2017. It's a well-known data set that has labeled network traffic flows from both normal usage and different types of attacks. Um, Here we have the link to the data set. The dataset includes features like packet size, flow duration, byte rates, and flags, so it's super useful. Since we're not experts in cybersecurity, we use ChatGPT to help us grow the feature or group the features into meaningful categories like flow-based features, packet-based features, control flags, and timing features. So this just kind of helped us get a better grasp of our features. And then we analyzed the data by combining the CSV files as we did down here. And then we also had ChatGPT help tell us which features might be high, low, and medium importance. And we dropped columns that were labeled as low importance. And then here's us dropping the low importance variables. And then we created a correlation matrix. Even though we have so many variables and it's kind of looks messy, it's actually very helpful if you look at these big squares. If you notice, a lot of them are about basically the same topic. It's just that they're mean, maxes, and standard deviations. So we were able to kind of look at where those squares were and then break down into um, just a couple things to keep out of that. So here's just our description on how we did that. So we identified the clusters of squares of red, as we called it, indicating strong correlations between certain features. These clusters often considered of variables that were measured the same underlying concept. For example, many features report statistics like min, mean, max, and standard deviation for either forward or backward traffic. So we just kind of chose one. So it reduced redundancy and simplified the model after we dropped them. And then here's a list of those. Um, Currently, we are okay, so sorry. This helped reduce noise and multicollinearity before feeding the data into our models. We're currently using logistic regression as a baseline model and random forest to improve performance by capturing more complex patterns. So we don't have any custom algorithms yet, but we've been using sklearn here. So we went ahead and broke into test and train, and here are our models, but we're still working on fine tuning them.
Yeah.
And
And
then
as for the obstacles that we have faced while working on this or that we might potentially face, understanding our data set, which was very large, was probably our first biggest challenge because there were a lot of features. So it was easy to get kind of confused, but we broke them down into categories as we talked about, and that helped a lot. And feature selection also took some time because we had to carefully decide what to keep and what to drop without losing any of the important information that we'd need later in the analysis. And for issues that we might face while working on this, um, one of them would be with class imbalance because in some parts of the data, there was way more normal traffic than malicious traffic. And lastly, we want to make sure that we evaluate our models properly. So we want to use accuracy, precision, recall, and F1 score. So that's something that we're still working through. And as for what's next, what we plan to do before we finish up our project, we plan to finish the training and testing both models, and then evaluate their performance and compare them for our analysis. And then we're going to decide whether we want to try any other algorithms such as SVM or tune hyperparameters on random forest. But that's everything for now, everything that we've worked up to currently. But thanks for listening and let us know if you have any questions.